Hey guys, we're going to be going over Earth Science, section 26.1, the sun and the solar system. It says in this X-ray image, our sun resembles a sphere-shaped volcanic inferno. Although the sun is millions of kilometers away, it is Earth's primary source of energy. How do the reactions inside the sun affect our lives? I'm going to go over the key vocabulary with you first. The key vocabulary: fusion. Fusion powers the sun and stars. This converts into energy. Plasma is the fourth state of matter. It's similar to a gas, but the atoms are different. They have positive and negative charges. The photosphere is the outer shell of a star, and one of the stars is our sun. Chromosphere is the outer atmosphere of the star. Sunspot is a cooler spot created by sun's magnetic field breaking through the surface. Solar wind is a flow of charged particles, which is that plasma, which transfers or travels through the solar system. And auroras are from the solar winds hitting our magnetic field that surrounds the Earth. And you can see those colorful and bright lights at the Arctic Circle and Antarctic Circle at the poles. I'm not going to read the section because you guys can either read it or you can listen to it on your Bookshare. If you guys want me to read it to you, give me, text me, email me, and then I can start doing that. Just let me know, okay? Down here is a picture that really gets into fusion of hydrogen into helium. And it's explaining plasma to you more technically with 4 protons, which are made up of 2 protons and 2 neutrons, and that is releasing some energy, okay? I'm also going to go over the section review. So it says, how does plasma differ from gas? So plasma and gas are pretty much the same thing, but plasma has different atoms. It is made up of positives and negatives. And if you go back to this section, you'll see you've got those protons and neutrons creating that energy there. So it says when 4 hydrogen nuclei or protons come together, they produce a helium nucleus of 2 protons and 2 neutrons. Then the energy is released in this reaction. Okay, so our next question says, describe how the temperature of the sun changes as you move from the sun's core out to the corona. So if you see my beautiful drawing here, you'll see that it's pretty hot in the core. And then it's going to drop about 6,000 degrees at the photosphere. And then it's going to get way hotter, 200 million degrees hotter at the corona. Okay? Number 3 says, how does the solar wind affect Earth? So you have these solar winds, and they are traveling, going, the word they use is permeate. So it's like to travel, but also to affect the area, the solar system. So these winds come, and they're going to bounce off the magnetic field that basically protects our Earth. And this is what causes those northern and southern lights at the poles, okay? And then our next question is critical thinking. Use your knowledge about Earth's magnetic field and solar winds to explain why these lights are not always visible from temperate regions, from mild regions. So our magnetic fields are pulled out at the poles. The auroras sometimes they're visible in middle latitudes. But generally they're going to be at those polar areas. Okay. The last one is 5, biology. Mars has either no magnetic field or a very weak one. Why does this fact make it unlikely that life exists at the present time on the surface of Mars? So, if you read the chapter and think about the magnetic field and those solar storms, or those solar winds, I should say, without a magnetic field or a strong one, the sun's winds are just going to really destroy the planet's ability to produce life or have life exist on it. So that's that for that one. Let me see. So I'm going to show you this page again of your key terms or your key vocabulary that you can go back and record. And then I believe I wrote down, I thought I did, it's a little messy here, but here's 4 and 5 that I wrote down. The northern and southern lights are only seen at the poles because of the Earth's magnetic field. The electrons are drawn in toward the poles. And then 5, without a magnetic field, the planet cannot be protected from the solar winds. Okay, so this is the end of section 26.1, and I will do 26.2 next. See you guys soon. Bye.